recording. Now I will share my screen. Bum 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 bum. Where I am? Oh, to share screen, and then I need our studio. Just a moment. Here it is. Okay, bingo. So I will start new script, new file, r script. I will name it. Just let me save it from the beginning. Documents are where it is. ISF. Just a moment. ISF R for finance, and it will be class V Fable package. Okay, it will be class 3 time series forecasting. Okay, first a technical. I will start with a technical question, but we need to work to discuss it a little bit. So I will first attach all necessary packages. We will need Lubridate. That's for working with dates. Working with dates. What else? We will need Fable. That's these are basic time series models. Time series models like ETS, ARIMA, and some more. Library feasts, that's for feature extraction plots, feature extraction plots. What else? Library. Yeah, we need also Fable data to not waste time on. Sorry, not Fable data, Siebel data. Siebel data. Yeah, yeah. That is some examples, time series examples, just to not waste time to download them, upload them. Okay, what else will we need? Fable, feasts, Siebel data. I'm not sure. Maybe we will need something more, but maybe that's fine already. I don't know yet. Okay, so click, 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 click. We have attached all the packages. Now, a little bit of discussion about how time series are stored in the memory and what you can find on the internet. Current settings are the following. R has a little bit of a historical advantage over Python in time series forecasting. Now this gap is diminishing, diminishing, and there are some methods that are realized only in Python, but the gap still exists. And for example, in R, all models, ETS, ARIMA, and so on are more or less standardized with the same interface, with the same ability to make interval forecasts, and in Python you still sometimes need to do some mumbo jumbo to obtain interval forecasts. Okay, so the problem is that the development for time series data mm, was not so long ago, and okay, for the moment there are basically there are many ways to store time series data in R. So there are many ways. That's a little problem, but there are many ways to store time series data in R. So historically, the first one was TS class, so TS data format. So then there are many like Zoo, XTS, and so on, because TS class allows to store only regular time series, that is for regular time series. But sometimes you need irregular time series, not monthly, not weekly, not quarterly data, but sometimes you need data with a lot of gaps and so on. So there were evolution process how to store them, and finally, for the moment, I think the most actual data format to store time series data in R is Sybil. So the first one, many time series data formats, and now that's Sybil. Finally, Sybil. So this format Sybil allows to store regular time series, irregular time series that have some key indicator, like in one big data set I can store data on production in different places. So it has basically, let's look at some data. I will take, I think house production is okay. Let us look at and one more package. Sorry, library tidyverse. Yeah, that's data manipulation. Okay, let's look at this data set. Glimpse house production. Okay. And what do we have here? Maybe head will be a little bit better. We have a quarter, so index variable. We have some indicators like the production of beer, tobacco, and some other things in Australia, because this package was developed by Rob Hindman and his team. They are in Australian universities. So, okay. Basically, what is Sybil format? That's a modern format. That's modern. It allows me to have a index variable. So we have index variable. So basically, it's time. It allows me some data columns. So in this case, it's beer, tobacco production, bricks production, and so on. And in this data set, it's absent, but there may be key like grouping variable. So I will provide you an example, grouping variable. So let me see some, I don't know, glimpse, what is some other example? Glimpse, I think they have that on tourism. I think that's it. No. What else can I save my time? Maybe house. Yeah, I think house retail, and there will be a grouping variable. Yeah. For example, this variable, this data set, house retail, we have two key variables, state and industry. So month is time. Turnover, it's the data column. And we have two key variables, state and industry. So for every state, for every industry, we have an indicator. Sometimes we have a key variable, and it may be character variable, like here, or it may be some other identifier for country, for region, for industry. So basically, in a Sybil data format, there are three kinds of variables: time, data columns, and the key that is to separate maybe the same beer production, but in that state, in that region, in that state. So basically, there are three types of columns in a Sybil data format. So basically, what is the structure of a typical Sybil data format? We have three kinds of variables. That's okay? That's clear? Any questions?
Oh, thank you, clear.
Okay. Uh, and if you search the web, the history is very long. There are a lot of, you may find a lot of tutorials that use all the formats like TS for regular time series or XTS or zoo. So if you will try to find um, some topics to some materials. So there are, let's say, few materials on Sybil. It's rather new format. It's very useful and handy, but the number of resources dedicated to Sybil is much less than to all the formats. So I strongly advise you to use Sybil if you work with time series data, but you should clearly understand that if you randomly search something on the web, probably the author of some old tutorial, even 2 years old tutorial, he will use the old TS class or maybe XTS or maybe zoo class to store data in memory. But basically, Sybil is much more powerful. But be ready that if you will find some old sources, 2 years is already old. No, so I would advise you to look where to look at the good. What is the good sources? I think the good sources is like if you go to Rob Hindman. So let's Rob Hindman, and if I go to teaching, so it's a good. So I will copy this to my uh, so Rob Hindman. So what are the good resources? Teaching page. So there you will find slides dedicated to uh, plotting, to forecasting using Sybil and Sybil data format and Fable package. Okay, and his book FPP, forecasting principles and practice. It's two FPP3. Bam, 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 bam. I will copy another link. Okay. So I strongly advise you to start there because there are a lot of codes, good examples, and um, so that's a modern style of working with time series. But if you look at 3 years old materials, they can be useful, but be careful because their old style and the good style, new style is much more powerful. Okay, that's a warning because there are a lot of changes breaking, so that's very that's very fun. Okay, let's move on to some real uh, stuff. For example, let's create Sybil new modern data format from nothing. Okay, let's create something like df, so some junk data set I will create, or I can load it from xls x file. I can say year equals to 2001, 2002, 2003, 2004, and some indicator. I don't know. So that's just an idea how to create a data frame. Oops, I forgot one small library. It's Sybil. Symbol. Okay, that's more than time series class. Okay, so for the moment it's not a symbol, it's an ordinary data frame. So we have two variables, year and x, and from the computer point of view, this variable year and this variable x, they are just numeric double precision DBL, double precision numeric variables, and computer for the moment does not understand that year is an index and x is a value. So from our human point of view, year, oh, year, it's an index. It gives me ordering of time series index as a value. But from computer perception, oh, you have a data frame with two variables, so I don't understand their roles. So I need to specify. So I just add some meta information about the structure of my data frame. So I say that df2 is as symbol df, and I should add that index is just year variable. Index is time. Okay, and now computer understands that my data frame has a very special structure. We have a year has a special role, and x is an ordinary variable, but I have indicated, I have added some meta information to my data frame, and now I can use a lot of plotting functions that will use this meta information about which columns has which role. Okay, let's do some, for example, autoplot df2 x. I think that will go. Okay, I understand that I have a toy data set, but my computer understands that year is a special variable. When I ask computer to plot a time series, um, yeah, Simon, I see, but just read your error and correct it. You see that a valid symbol, so just read what's written. A valid symbol must have distinct rows. So you cannot have two. So if I will do, what is the reason of your error? If you do like this, so you may have the same values for x. You may have the same values for x. That's okay to have 2, 4. That's okay. Even 3, 4 is okay. So 4 here, 4 there, 4 there, that's fine. But you cannot have 2001, 2002, 2003, 2004, 2004. That's a bad index. No duplication in index. So it will say me that as a just as a usual data frame, that's okay. In df, variables have no specified role. So year is just a variable. But if I try to convert it into symbol, then I should avoid repetitions in index, or if I have many, so I may have repetitions in index if I have specified the key. So let me look at the result. So it will say, no, that will not go like this because I have 2004 twice. That's not okay. But if I have here 2005, that's okay. That's okay. Or there is another possibility. I may have repeated values. So I may have, let's say, so I may have repeated values. So I may do like this. I may have 1, 2, 3, 4, 5, 6, 7, I think, like this. But I need to specify a key. For example, that may be for different city. So there may be city like Moscow. Moscow. I may have the same year, but for different cities. So I may have St. Petersburg. So I may do like this. So I have a repetition in year. Sorry, 999. What's the problem? I have a comma. Okay, so I have the same year, but the same year 2001. Here it's for Moscow, and here is for St. Petersburg. So when I specify as Sybil, uh, it says, oh, duplicated roles, because I have not specified the role of city variable. So if I specify that key variable is city, so that will work. When I look at df2, I will have a year, x is my data column, and the city is a key variable. Okay, Simeon, everything is right? And I may have a plot. So now I have a two time series, basically, one for Moscow, the other one for St. Petersburg. So that's an idea how to create a Sybil data frame. So you have ordinary, you start from ordinary data frame, and then you specify to convert ordinary data frame. We have worked last week and 2 weeks ago, we have worked with ordinary data frames. So that's not a problem for you. You are already a little bit familiar with them. So you start with ordinary data frame. For ordinary data frame, computer does not care about whether the year is repeated. It's okay. Whereas so there are no such strict requirements for ordinary data frame. But when you convert an ordinary data frame to its Sybil format, you should specify key variable or key variables. They may be city and I don't know regions and cities. So there may be a lot of key variables. There may be country, region, city. There may be three or even more key variables. One variable is a date, and all others variables will be considered as data variables. Okay, I have converted. So basically, we specify index. That means time. We specify key. So like regions, etc. And we specify roles of columns and data columns. Okay, when we have specified the roles of the columns, we have a Sybil. So in Sybil data format, we have three roles for variable, three possible roles for variable. Okay, the idea behind the Sybil format is clear. Yeah.
Yes,
Any
Professor.
questions? Okay. So let me, yeah, there may be some problems when you work with data, with dates. So basically, what are the possible, so dates that may pose a problem? Dates, working with dates. So I will specify here. So it's Sybil data class. Now we have working with dates. Working with dates. So normally when you read data from Excel file or from CSV file, you will have character strings. For example, this variable to 2021 01 28, as far as I remember, it's a string, it's a character variable. Okay, if I look at class of it, it's character. That means computer does not understand the structure, so it's just plain string of characters. So okay, and we need to transform it into date. Computer should understand, oh, 2021 is a year, 01 is a month, 28 is a day. So basically, what dates may you have? So you may have yearly data, yearly data. So that's the most simple. You just can write numbers. So that's the most simple format. So you don't need to, basically you just write numbers and that's all. So basically, if I write something like df, so where is, so that's okay. I don't need, so we have already seen this example. Basically you just write the year as number and that's fine. Okay, what about monthly data? Monthly data. You will find. So let's use some transformations from character to date time to year month special format. So we have. So basically, we have three workhorses. So I would like to specify three workhorses. We have three basic useful functions like IMD, DMI, or maybe even more. Maybe not three, but MDI and so on. So basically, that means that year is the first, month is the second, day is the third. So in this example, if I just I understand that here year is the first, second is a month, and third number is a day. So I will say EIMD, YMD, and it seems that the result is the same. But if we look at class IMD, you see that's a date class. So computer understands now that that's a date. And for example, I may do some, what's the advantage over just character representation? I can do a lot of arithmetics like plus days 4. Okay, yeah, if I add 4 days up to the current date, I will obtain the first February. Okay, so here I have done transformation from just character class to date class. And when I work with dates, I have a lot of arithmetics. Computer will understand that these dates when I plot time series data and so on. So basically, how would I transform? We have, for example, American notation. They start from months, then they write day, and then they write year. So they would write current date as 28 the 1st 2001. How can I convert this into a honest date? I should say the first is a day, D, the second is months, M, the third is year, DMI, and basically that's okay. It's automatically transformed into year, months, day, the biggest unit, the medium unit, and the smallest unit. They're sorted. And I can, I don't know, add days 30. Okay, we have transformed character dates into date class. So we have transformed. So first action may be from, I will specify from character to date class. So the first thing we often need is to transform just plain string into a honest date. Okay, for the moment, everything is clear?
Yes.
Clear.
Okay, Now, when you work with daily data, that's all you need. When you work with monthly data, to specify that, because computer will not understand if you have something, if you have a data set like this, 2001, 12, 01, I don't know. If I will have something like this, and I have some values. I don't know. Computer cannot understand whether it's a monthly data or whether you have daily data with a lot of gaps. So maybe you have monthly data, maybe you have daily data with big gaps with 20. So that, so there are special date types for monthly, for quarterly dates. So there are some special classes for monthly and quarterly dates. So let me provide an example. Let me have something like table will be, my df is so let me start. Imagine that I've read some data from xlx file, and I have months like months like C, and I have here 0101. So let me provide some real life example like 3, like 4. So imagine I have read the data like this, and I have, oops, disappeared, and I have some x that is, yeah, like this. I have a small data set. Okay, I have months. For the moment, it's character. I have x, that is my variable of interest. So what will I do? I will transform character to date and date to a special type year months. So I will transform months from character class to date class. I will say df equals to mutate df. So df2 equals to mutate df, and months will be ymd of months. So let me look at the difference. Glimpse df, I have months, that is character. If I look at glimpse df2, I have months, that is it has a special class date, and computer now understands that this date is bigger than that. We can calculate time difference and add time intervals and so on. The second action will be I will go from date to year months class. So that's a special class that says I'm working with monthly data. That's not daily data with big gaps between them, but that's a regular dates without gaps. So now I move from date class to year months class. Okay, df3 equals to mutate, df2 months equals to year months, and glimpse df3 it has a special type. So now computer understands that I have monthly dates. Okay, so I have moved from character to special type date, and from date to year months. I can do in one line. I can do something like df3 bis equals to mutate df year months ymd months. I can do like that. I can do in one line, but to better understand the logic of transformation, I have done like this. Okay, that's clear. So how to transform strings, characters into dates? Yeah. Any questions?
No, it's
Yes.
clear.
Now I can
I have a
say that.
question.
Yeah.
What if we have another separate sign, like dots or commas?
Now that doesn't matter. So if you have that doesn't matter if you have 0, 3, I don't know, 0, 9, something like this. So if you say that it's so the first is day, the second is month, this is year. Yeah. So I write day, month, year, and it will work. This function, this family of functions, YMD, DMY, MDI, and so on, they don't care about the separator. Any separator will do. So if you have points or minuses, that's fine.
Okay, clear.
The only important is the order. So if you have a character string with 3 numbers, you can easily any separator. I think the space is also okay. So let me check, but I think that's it checks whether there are 3 numbers. Yeah, that's okay, like that. So if you have 3 numbers in any order, you should understand the order and write the DMI in the corresponding order, and you will transform this character string to I think yes, Simon is right. Even if you have no separator, but the length is okay, so you have 6 total lengths, it will understand. Yeah, that's very convenient. So that's why I called them workhorses. So basically, you have a raw data. Data is specified in some form. You use IMD, DMI, MDI, because maybe this data source is American, maybe data source is Russian. So you need to just be careful. What is the first number? What is the second number? What is the third number? Then you transform to date class. If you have daily data, that's all. You have done transformation. If you have monthly dates, then you need to specify that only year and months are important. Basically, that's all. Okay, now we learned how to, so for the moment, what we have done, because data transformation takes a lot of time, model estimation is very fast. Believe me, the most, you will spend more time on data transformations than on model estimation, because data cleaning is a very long process in real life, and model estimation is fast. Okay, so is there a DMI type command for hourly data? Yes, there is. I don't. I have no experience with working with hourly data, but yes, you have. Yes, there is. So the answer, is there a type command for hourly data? The answer is yes. I don't remember, just I have no experience with hourly data. Normally I have forecasted Russian macroeconomics data and monthly. That's my experience. But just a moment, I will think a little bit You certainly have, but just a moment, I will pull. So the answer is yes, but the so let me look at just a moment. I think you have parse date time. Yeah, you have parse date time. So if you like to work with hourly data, so you need to have something like that. For high frequency dates data, you will need to have time, something like that. To do what's wrong? What's wrong? Because it's example of what is wrong, but you need parse date time. Yeah, let's consider that example. Yeah, I think that works. So there are class of functions that works with geographic coordinates. So you just add a separate variable like geographic coordinates. So it will be your. So the question is there some class of functions that may work with geographic coordinates? So you have just a separate column. You don't add the coordinates into the date. So basically, you have something like this. You have time, and you have your geographic location, and it should be a separate variable. So index is just time. If you have data, I don't know, for London Stock Exchange, for Tokyo Stock Exchange, so you create a variable that is Tokyo, London, and so on. So basically, that's done by using one ID or two or three, maybe country, stock exchange. So you may add many more variables, non-numeric, into a Sybil data format. From coordinates to cities, region, countries. Yes, I think you may use standard Google requests. So the answer is yes. I haven't done this personally, but I have done like experiment. But yes, there are some functions, other functions to transform coordinates into cities, regions, countries. Yes, there are such functions, but I have no experience, so you need to Google by yourself. If you fail, just I can try to do it myself, but I think you. But yes, there are functions like that. Okay, let's move on. Now a little bit of time series plots. So imagine we have done. We have correctly specified date structure. We have transformed our data set into Sybil, and now everything is fast. When you have correctly recognized date, when you have converted your data set to Sybil, you have done 80% of the work. So now everything is fast. Would you like to plot? So basically, if you these two sources are excellent. So that's a good place to start how to work, or if you'd like to know how to work with time series in R. Okay, so now everything is fast. Let's make some plots. Make some plots. Okay, I will use built-in data set. So first, autoplot function is very powerful. I may say autoplot something like, I forgot the names of the columns. Sorry, glimpse, aus production. That's autoplot, aus production, and I may say beer. Okay, that's a beer production. Yeah. Okay, what I may have, that's quarterly data. So we have seasonal plots. So we clearly see seasonal effects. So let's plot something like GG season, aus production, and beer. Okay, what do we see here? In this data set, we have quarterly data. So we have 4 observations for each year. And as we have 4 observations for each year, we may cut all the years and stack into one first quarter, second quarter, third quarter, fourth quarter plot. So basically from this plot, we clearly see that beer production is less in second quarter and third quarter of the year than in the fourth quarter. And we see a long-term tendency that if we go from 1965 to 2005, so the beer production is growing. Okay, so from this plot, we see seasonal effects and we see global trend. We may, on the other hand, we have a GG subseries plot. We have GG subseries plot is basically the idea is the same, but it just uses a little bit different slicing. So the slicing is different. So basically, what do we see here? On the previous plot, we have Q1, Q2, Q3, Q4 on the horizontal axis. And on the subseries plot, we see that year is on the X axis, and Q1, Q2, Q3 are just the tiles. So we have 4 tiles, 1 tile for first quarter. Basically, that's the same thing, but we see the seasonal pattern from other viewpoint. But basically, it's just the same plot. What we can do more? We can plot something like GGTS display, aus production, and the variable. So what do we see here? Here we see 3 plots combined at once. The upper one is more or less intuitive. It's just the original time series. The horizontal axis is the time. The vertical axis is the value of variable I have selected. And below I see 2 plots. On the right, we have a seasonal plot to see, to understand visually which season has, in which season we have more or less beer production. And on the left bottom plot, we see what is called ACF. That's autocorrelation function. Who knows what is an autocorrelation function? What is autocorrelation function? What is this? It's on the bottom left plot. What is
the function of the covariances between
the variable at time t and its flag, k flag.
Yeah, exactly. You have two interpretations of the bottom left plot. For example, if I consider, let's say, lag equal to 2, yeah, I have 0, 5 here, yeah. If I look at the ACF2, it's approximately plus or minus 0, 5, yeah, from the plot. So what does it mean? That means that the sample correlation between yt and yt minus 2, because it's lag2 autocorrelation function, is equal to 0, 5. Or we have another interpretation. We may say that no, first interpretation, and we have a second interpretation of autocorrelation function. Second interpretation of autocorrelation function. If we do a ordinary simple regression, if we just do OLS hat yt is equal to constant is missing, but the slope coefficient before yt minus 2 is 0, 5. So I don't know the intercept. Let's call it intercept. I don't know the value of intercept, but if I just will do simple regression of yt on lagged value of yt minus 2, I'm speaking about autocorrelation at lag equal to 2. So this slope coefficient will be 0, 5. And for example, if I look at the autocorrelation at lag 4, it's roughly, I don't know, 0.8. I may get numbers if I'd like. So to get to real numbers, I need to do something like ACF, house production and beer. So these are actual autocorrelation functions. So these are values. So if I like to have numeric values, not on the plot, but numerically, then I have. So at lag 4, it's much more higher than at lag 2 or at lag 5. So once again, on this plot, I clearly see that I have quarterly data, because the autocorrelation has spikes at lags 4, 8, 12. That's the sign of seasonal data set. Boom. I think that basically, sometimes we can specify something like we can, there are some more plots, but I think basically for regular time series, no. You have, once again, we have a GG, one more plot that may be useful, GG lag. Yeah, one more plot that may be useful, GG lag production and the variable beer. Okay, what do we see here? That's a little bit, you need to get used to this plot. But basically, what is showing me is on one axis I have, so if I consider the first tile, I have 9 tiles here. But if I have, let's say, let's consider the first tile. So on one axis we have yt minus 1. On the vertical axis we have yt. So we try to understand the dependency between current value and previous value of yt. On leg 2, we try to understand on one axis we have yt minus 2, and on the other axis we have yt. So you need to get just used to this plot. But if you understand that that's a plot, just on one axis we have yt on one axis and yt minus k on the other axis. So for example, what do I see if I look at the leg 4? If I take yt minus 4 on one axis and I take yt minus 1 on the other axis, I see that I roughly have my observations basically are located on a line where yt is equal to yt minus 4. So basically in my data set, yt is equal to yt minus 4. They are on a line that is exactly separates my plot into two parts. And basically, once again, from this plot, I see that I have quarterly data. I can understand which quarter on average is bigger, but maybe the most suited plot for that is GG season. But anyway, sometimes GG lag is useful because it compares current value with past lagged values. So on one plot, sometimes it's useful. Okay. Yeah. Any questions about plots?
Oh, I have a question. So this line, which is dashed lines, it's just 45 degree, right? It's not the
Yeah. Yeah.
Right.
When horizontal value is equal to when yt is equal to yt minus. So if I consider this plot, this dashed line is a line where yt is equal to yt minus 5 because it's a tile for leg 5. So yellow observations, if we are in quarter 4, yt is higher than yt minus 5. And that's okay, because if we look at the first GG season plot, we see that in the fourth quarter, observations are bigger than 5 quarters before. Fourth quarter will be quarter number 3. Yeah, and I see that quarter number 4 will lie higher than 5 observations before. Yeah, because 5 observations before will be previous year quarter 3. Okay, let's move on. Yeah, you may obviously I have done so obviously you have some you may just change you may tweak your plot, so that's you may I don't know, you may say that what are the standard tweaks. You may say ylab is so you may say what is the standard GG title. You may say something like beer production in Australia. You may say ylab. So let's check the units, and xlab is time. ylab, I don't remember what are the units. So if I look at house production, it's a built-in data set. So we have beer production in megaliters. Okay, I will say that it's beer production in million of liters. Oh. So you may tweak the plot. There are many tweaks possible. Basically, the most useful tweaks are labeling horizontal axis and vertical axis, because that gives us a lot of information, but you may tweak more. I think that's all with time series plotting. Okay, now let's move on to something. What may I extract from time series? What we may extract from time series? We may extract ACF, house production beer. Oh, that's autocorrelation function. We have some plots. What we may extract from time series autocorrelation function. We may also extract partial autocorrelation function. What is partial autocorrelation function? What is partial autocorrelation function?
Projected values of YT on all values in.
Sorry.
It's a residual value of YT after projection on every on all values in time series, and for instance YT -1, and correlation between the residuals of these variables.
Yeah, you're right. So you may say that what is so let me look at some partial autocorrelation value. Let's say at the third one. Yeah, we have once again two interpretations. So let's say partial autocorrelation function at lag 3 is equal to 0.57. So what does it mean? The first interpretation is a correlation between YT and the YT -3 cleaned from YT -1 and YT -2. Yeah, that's the first interpretation you have mentioned. So if I will clean YT from the effects of YT -1 and YT -2, and I will calculate some kind of like direct effect of YT -3 on YT. You have a correlation interpretation. Correlation interpretation, and you have once again regression interpretation. That's basically if I will estimate multivariate regression. So if I estimate with ordinary least squares YT on intercept, on YT -1, on YT -2, and on YT -3, I will get this number 573 before before the third regressor. So that will be hat beta 1, there will be hat beta 2, and there will be this number 0.573 before the third regressor. So basically there are 23 multivariate regressions estimated on this plot. This is the coefficient before yt minus 1. When I try to predict yt with previous values, this is the coefficient before yt minus 4. If I try to predict yt with yt minus 1, yt minus 2, yt minus 3, and yt minus 4, and so on. And once again, I see the spike on the most prominent spike is on the fourth leg. So once again, even from this partial autocorrelation plot, I see that I work with quarterly data. Okay, what else can we extract? There are a lot of things we may extract. So basically, FIST's package contains all the things about plotting and statistics extraction. So what maybe what is we may partial autocorrelation function. What else? That's about decomposition. Yeah, for example, who knows about unit roots tests like Dickey-Fuller, Phillips-Perron, and so on?
I heard about them, but that was a long time ago.
Okay, so yeah.
Are those the tests for stationarity?
Yeah. You are right. You have information about the order of so you have you have unit root tests for basically the most popular statistics today is KPSS, not Dickey-Fuller. Long time ago, Dickey-Fuller was much more popular, and in some books, usually books because they because when a book is published, they have some reprintings and so on. And in books dedicated to time series, you will encounter mainly Dickey-Fuller statistics. But KPSS is much more popular now because when you decide whether to take the difference or do not take a difference of time series, then it happens out that the forecasts based on automatic selection, on automatic decision whether to take difference or not to take difference, this decision is gives on average, not for every time series, but on average, using KPSS test is gives better predictions on average than using Dickey-Fuller test. So nowadays, Dickey-Fuller is a little bit less popular than old times because after massive time series competitions like M4 and as far as I understand, ongoing M5, when teams compete to forecast hundreds of thousands of time series, then it happens that KPSS works better for automatic forecasts. So when you pick up one time series, then you may maybe for some specific time series, a decision based on Dickey-Fuller is better, but on average. So let's just use KPSS and not Dickey-Fuller by default. Maybe I will check some example. Oops. Okay, we need time series and we test, so we basically can do something like unit roots, like house production and let's say beer. Yeah. What's wrong? House production. Oh, just a moment. Let me look at the table. Maybe double brackets because I need to transform it into numeric vector. Yeah, like this. In this case, do I using KPSS test? Do I reject the null hypothesis? And what's the null hypothesis in KPSS test? What's my conclusion about stationarity?
The null is that the series are stationary.
No, it's not like Dickey Fuller. So H naught is TS is stationary, and H in Dickey Fuller you are right. With Dickey Fuller you are right, but not with KPSS. It has different null hypothesis. In Dickey Fuller test you are right. The null hypothesis is that time series has unit root and so is non-stationary. But for KPSS test, that's an exception. It has zero, the null hypothesis that time series is stationary and alternative time series is not stationary. So in this case, we have p-value. P-value is 0.001. Let's say it's less than 0.5. Let's use 0.5% significance level. And so the conclusion is that H node is rejected. If I have selected 5% significance level. Okay, there are many more things that you can do to automatically extract some strong. You may extract seasonality measures, how strong is seasonality, and so on. There are many things to extract. So basically, I have only 4 days to introduce you to R and into this package. So my idea is just you should be able to convert dates, to create a Sybil class, to plot. You have a lot of basic plots, to extract some indicators, and then we will move on to forecasting. Okay, let's make a break of 10 minutes and we will continue with forecasting after 10 minutes. Okay, any questions?
Sorry, and the function unit root KPSS, does it belong to what library does it belong to? What package?
I think feasts. I think that's feasts. That's like feature extraction because it's a feature of time series. For time series, we have one observation that is KPSS statistic. So basically, it's feasts package. Feature extraction like tests, time series tests are here. Okay. Yeah. Probably it will install some other packages. Yeah, that's okay. Yeah, there are a lot of dependencies and to maybe we can, maybe there are some dependencies. Yeah, help package equals to like feasts. And if I look at the description, It depends on Fable tools. Maybe some. So I see that FIST package depends on that packages, but maybe these like Table, Fable they may depend on other packages. So maybe you need Urca package that units. Urca means unit roots and integration analysis. Yeah, that's also a popular package for unit root tests. So Simeon, unit roots KPSS is in FISTs, I'm pretty sure. So if I look at,
Thank you. I found it.
yeah. Okay, so let's make a break for 10 minutes and we will continue with forecasting.